Last class, we had ended by learning about how to calculate vertical asymptotes from limits and how to deal with the situation of a constant over zero when it arises. So today we're going to finish that, and then we're going to look at horizontal asymptotes. So vertical asymptotes slash limits, I'm sorry, infinite limits. And this is the case of a constant over zero. And last class, we wrote down some steps for dealing with this, so we're not going to rewrite them down. We're just going to go straight into doing a few examples. Whew. And we'll see if you guys remember what to do. So step one, plug in. What do I get when I plug in that zero?
4 over 0?
Yeah.
I get 4 over 0. So what are the possible values that this could take? I don't have 0 over 0, I have a constant over 0. What are the possible answers?
Infinity, negative infinity, and does not exist.
You got it. So I have 3 possible answers: infinity, negative infinity, and does not exist. Can I get rid of the does not exist possibility in this case? Oh gosh.
No.
It's your fault, Luca. I cannot. We can only get rid of it when we have a one-sided limit. I don't have a one-sided limit here. So this is not one-sided. So what do?
We look at the left and the right.
I look at the left and the right. So here I have 0. And it's getting a little bit easy to get confused with 0. What's a good value on the left side of 0?
Minus 0.1.
Minus 0.1, and on the right side of 0?
0.1.
Positive 0.1. So that's my 0 from the left, and that's my 0 from the right. And now, what do I plug these values into?
X.
Plug them in to the x in that function. So I'm like, negative 0.1 plus 4 over negative 0.1 squared times negative 0.1 plus 2. Do I care about the value?
Not really, just about the symbol.
Only the sign. So is this positive or negative?
It's negative? Oh no, positive, sorry, positive.
Positive. You guys can plug it into your calculator. A thing you're going to see me do sometimes is look at each of the separate factors. So I'm like 4 minus 0.1. Well, that's clearly positive. Negative 0.1 squared, that's clearly positive. And 2 minus 0.1 is also positive. So I look at each of the separate factors to kind of break this down into smaller parts. And I get that this is a positive value. So I'm going to put my little plus sign here. And now I'm going to do the same thing with 0 from the right. 0.1 plus 4, 0.1 squared, 0.1 plus 2. And in this case, again, each of those separate parts is clearly positive. Oh, oops. What do those positive mean?
That is a positive infinity?
That is a positive infinity. These are both the same. Which means it's going to positive infinity on both the left and the right. Which means that my final answer is therefore positive infinity. Is this bringing back memories of Tuesday?
Yeah. Yes.
Good news. Let's do one more, and then we're going to see how sometimes 0 over 0 can turn in to a constant over 0. But first, let's make a conclusion about continuity. Is this function continuous at 0?
No.
What kind of discontinuity does it have?
Infinite discontinuity.
You got it. So here I can say that there is an infinite discontinuity at x equals 0. Wasn't part of the question, but it's something that we learned from doing the question. Okay, we'll just do one more similar to make sure that we really got this, and then what do I get when I plug in?
8 over 0.
8 over 0. So be careful, because I've seen a lot of people in my other class saying, oh, look, it's 0 times 7 on the bottom, therefore it's 8 over 7. We're multiplying by 0 on the bottom. That means it's 0. Multiplication by 0 is always 0. So here I'm going to get 8 over 0, which means, again, this is either infinity, negative infinity, or it does not exist. We're going to do the same thing to figure out which one. I want to look at 5 from the left and 5 from the right. What's a good value on the left side of 5?
4.9.
And on the right side of 5?
5.1.
You got it. So let's plug in those values. 4.9 plus 3, 4.9 minus 5, 4.9 plus 2. And I get positive, negative, positive. There's one negative and two positive, so that makes this thing negative. So I stick my negative in there. And then for 5 from the right, I do something similar, but I plug in 5.1. And now I have positive, 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 which results in a positive. They're different. What does that tell me?
Doesn't exist.
Does not exist. It tells me on the left side I'm going down to negative infinity, but on the right side I'm going up to positive infinity. So then my final answer is that D and E that we had right there. Are there any questions about this? Okay, so in each of these cases, we plugged in and we just immediately got that constant over 0. Sometimes, though, we're going to have to do work to get to the constant over 0, because sometimes when we plug in, we're going to start off with a 0 over 0. So we're going to look at when 0 over 0 turns into a constant over 0. And these questions are somewhat annoying because it often feels like you do a lot of work for nothing. What happens when I plug in?
0 over 0.
I get 0 over 0, which we know is an indeterminate form. That means that we should do something else. What's the factor that I know I have?
X minus 4.
Exactly. I'm trying to eliminate my x minus 4. What method am I going to use in this case?
Rationalize.
I'm going to rationalize. You got it. So I'm going to say root x plus 5 plus 3 over root x plus 5 plus 3. Which will give me the limit as x approaches 4 of x plus 5 minus 9, x squared minus 8x plus 16 over root x plus 5 plus 3. What's x plus 5 minus 9 equal?
X minus 4.
Yay, we found our x minus 4. So how can I get my x minus 4 in the denominator?
Factorize x squared minus 8x plus 16.
Ta-da! So what's my other factor going to be when I factor out the x minus 4?
X minus 4 times x minus 4.
You got it. So now I can cancel out some of the x minus 4s. What's left in the numerator?
1.
Yes. Hello, sorry about that. It's happened a lot today. I don't know what's going on here. Exactly, so I have a 1 left in the numerator. Good. Now what happens when I plug in?
1 over 0.
I get 1 over 0. You got it. I get 1 over 0, which means that this is either infinity, what's happening, or negative infinity, or does not exist. So even though I started with 0 over 0, once I eliminated the factor that I knew that I had to eliminate, it's gone. I still didn't have an actual answer. I had a 1 over 0, which means that now I can apply the method that we've been doing today and that we learned at the end of last class. So I need to look at the left and the right side of 4. What's a good value on the left side of 4?
3.9.
3.9, and then we'll go with 4.1 over here. So that's 4 from the right and 4 from the left. And we plug these things in. Do I need to plug them into my original thing, or do you think I can plug them into the thing after I canceled?
Well, the last one.
I can plug into the last one. You got it. So I'm going to have 1 over 3.9 minus 4, 3.9 plus 5, plus 3, which will give me a positive on top. 3.9 minus 4 is negative. That thing, root 3.9 plus 5 plus 3, clearly must be positive. So this gives me a negative value. Again, you are welcome to plug these things into your calculator to see, but sometimes it's faster if you're able to separate it into little chunks like I'm doing here. Do you guys understand how I'm separating it into chunks like that?
Yep.
Yep.
Okay, so then let's look at 4 from the right. And I'm going to have 4.1 minus 4, root 4.1 plus 5 plus 3. And now I have plus, plus, plus. So what's the final answer?
Doesn't exist.
Ta-da! So like I said, sometimes it can feel like you've done a lot of work to get a D and E, but it was still necessary in order to see that this was D and E. That's my final answer. Are there any questions about this? Good. So from your group work, I noticed that a lot of you seem to be having trouble with the clearing denominators questions. So I'm going to do a clearing denominators question that has 0 over 0 turn into a constant over 0, and then we're going to move on to the next problem, or the next topic. Oh, hello, Maureen. So as usual, step 1 is to plug in. I have 2 over x plus 1 minus x plus 2 over 10 all over 2x squared minus 12x plus 18. What do I get when I plug in?
Probably 0 over 0.
I get 0 over 0. And so in this case, it's important to I'm going to do this in 2 steps because I'm going to get 2 over 4 minus 5 over 10. And then I do get that 0 on the bottom. It's important to recognize sometimes that your fractions, while they might look different, are the same. 2 over 4 is a half. 5 over 10 is a half. So this is a half minus a half. That gives me a 0 over 0. Good. So what method am I going to use in this case? Which of my 3 0 over 0 methods?
We're going to clear the denominators.
I'm going to clear the denominator. So what am I going to multiply the numerator and the denominator by?
X plus 1 and 10.
You got it. I'm like x plus 1, 10. X plus 1, 10. And what's the factor I know I'm trying to get rid of?
X minus 3.
X minus 3. Okay, I'm going to do this a little bit slowly. I'm actually going to move this right here to another place. We'll just have this as so I can see that I'm taking this x plus 1 times 10 and distributing it to the inside. So both of those things on the inside are getting multiplied by both x plus 1 and 10. So with my 2 over x plus 1, the x plus 1's cancel out. And what is 2 multiplied by?
10.
10. And then minus that x plus 2 gets multiplied by what?
X plus 1.
You got it. Question. Can I cancel out now? Can I be like, yay, x plus 1, goodbye?
No, distribute.
No, good. So first of all, I'm not allowed to do that because x plus 1 isn't a factor of the top. There's that minus sign that's separating, that's stopping me from being able to do that. This minus sign is all like, no, don't cancel. But second of all, I'm trying to cancel out x minus 3. I have not yet found my x minus 3. Until you have the factor you're trying to cancel, control yourself. Just don't cancel anything. It might be tempting. Hold off. Don't cancel. Wait until you get to the x minus 3. So we're looking for the x minus 3. We're going to expand. And I'm going to get, limit as x goes to 3 from the right, 20 minus x squared plus 2. Are you 2x squared minus 12x plus 18. X plus 1, 10. Is that good? Did I do everything right?
$16.
16. Huh? I'll give you a hint. I made 2 mistakes.
Yeah, no, right. Your multiplication. X plus 2 times x plus 1 is x squared plus 2.
Yes, x plus 2 times x plus 1 is not x squared plus 2. What is x plus 2 times x plus 1 equal?
X squared plus 3x plus 2.
You got it. So what I did is, so here we're supposed to be foiling. We're doing F, first, outer, inner, last. I didn't do FOIL, I did like FLO. I just did the first and last. That's not okay. So that's not x squared plus 2. I need that plus 3x in the middle. I need my outer and my inner. What's my other mistake?
You have to distribute the minus.
Ta-da! You have to distribute the minus. I'm going to call it the parenthesis problem. I need parentheses around this thing. I'm subtracting the whole thing. Without those parentheses, that's wrong. So those parentheses need to be there. So I limit as x approaches 3 from the right. That minus sign is getting distributed to the inside. So I have minus x squared minus 3x. 20 minus 2 is plus 18. Okay. Did I make any mistakes? Are we good?
Nope.
Everyone agree?
Yeah.
Good. You're right. No mistakes. Now, remember, the factor that I'm looking for is x minus 3. So I'm going to now factor that out of the numerator and the denominator. When I factor it out of the numerator, what does my other factor have to be?
Negative x minus 6.
Negative x minus 6. You got it. What do I multiply x by to get negative x squared? Negative x. What do I multiply negative 3 by to get positive 18? Negative 6. There we go. I love your background. It's wonderful. I could put a background, but I look really super weird when it happens. Hang on. I'll show you what happens when I put a background. Do you guys want me to teach like this? Yes, we all think this is good. Hi, Alex. Okay, I will stay this weird invisible cupcake sucker thing. Okay, so what about the denominator? If I factor out my x minus 3, what's my other factor have to be?
X plus 6.
2x plus 6, are we sure?
Minus 6.
It has to be a minus 6 because we need that positive 18. Then x plus 1,
Yeah.
then 10. So do those x minus 3s cancel out? Yes. Goodbye. Goodbye. Okay, now I have this. So this is the limit as x approaches 3 from the right of minus x minus 6 over 2x minus 6, x plus 1, 10. And what happens when I plug in now?
It's minus 3 over 0? Oh no, you get minus 9 over 0.
Minus 9 over 0. Perfect. So I have a minus 9, and then on the bottom I have 0 times 4 times 10, but it's times 0, so it's just 9 over 0. So my possibilities here are infinity, negative infinity, and does not exist. Can I get rid of any of those possibilities?
Yeah, it doesn't exist.
Does not exist is not going to happen here because it is one-sided. Yay, that makes our lives easier. We only have one thing to plug in. So I have my 3. What's a good number on the right side of 3?
3.1.
Yay, 3.1. So 3 from the right. I'm plugging in 3.1. And I'm like minus 3.1 minus 6. 2 times 3.1 minus 6 times 3.1 plus 1 times 10. And when I check this out, I'm like, that's positive. Guess what? That's positive, that's positive, that's positive. I'm sorry, the top is negative, not positive. And so this whole thing is negative. So what's my final answer here?
Minus infinity.
Minus infinity. Okay, so David was doing a lot of answering, but I didn't really hear a lot from the rest of you. Did you follow? Are there any questions? Does this make sense? Okay. What kind of discontinuity does this function have at 3?
Infinite discontinuity.
You got it. So before, when we saw 0 over 0, we always had the result of a removable discontinuity. But this time, because we had an infinity as our answer, this is an infinite discontinuity. Let me know when you guys are ready to move on, because we're starting a new topic now.
I'm ready.
The rest of you, if you could just like also use your voices or in the chat, tell me ready, something like that.
I think we're all ready.
Cool, thanks.
Yep, we're good.
You guys are all alive, you're here. Okay, so next we are moving on. It might not bother you, but it's actually bothering me. Give me a second. Ah, no. Okay, so we are moving on. Here we've been doing limits that give us vertical asymptotes whose result is infinity. But before we saw that if our x is approaching infinity, that gives me a horizontal asymptote. So we're going to look at horizontal asymptote limits at infinity. And we're going to start off in the same way that when we started off 0 over 0, we started off by understanding what division by 0 meant. We're going to start by trying to understand what division by infinity means. So let's say that I have the limit as x approaches infinity of 1 over x. What is this thing asking? It's asking me what happens to the value of 1 over x as I let x get bigger and bigger and bigger and bigger and bigger forever. So we're going to do a really similar thing to what we did when we understood that dividing by 0 meant infinity. We're just going to start with like 1 over 1. What's a value that's bigger than 1? 2. Let's go that. 1 over 2. So which is smaller, 1 or 1/2?
1/2.
1/2. What's a value bigger than 2?
3, 4.
3, 4. Why don't we go with 5? 1 over 5. Which is smaller, 1/2 or 5?
1/5.
1/5, yeah. Okay, let's get way even bigger. What if I'm like 1 over 848? Is that a really small value?
Pretty small.
Yeah.
Pretty small, right? So I got even smaller. What if I'm all like, actually, let's get super big. What about 1 over 848,484,848?
Yeah, that's a bit smaller too.
That is way smaller. And what if I'm all like 1 over 9 billion? Is that like extra super small?
Yeah.
So as I let the bottom get bigger and bigger and bigger, what's happening to the value?
Getting smaller.
It's getting smaller. And is it going to keep getting smaller forever as I let that bottom get bigger?
Yep.
What's it going to get closer and closer and closer to?
0.
0.
Negative
0.
infinity.
So as the denominator gets bigger and bigger and bigger, the value gets smaller and smaller and closer to 0. We could even say that if infinity existed, we would expect for the value to be 0 at infinity. So in other words, we can say that the limit as x approaches infinity of 1 over x is equal to 0. So in the same way that a constant over 0 meant infinity, negative infinity, or does not exist, a constant over infinity, it doesn't matter if that's a 1 on top or a 7. A constant over infinity, and that infinity can be positive or it can be negative, always means 0. And you need to know that. There is one exception to this rule. And that exception is similar to the exception that we had with 0 over 0. We were like, division by 0 means infinity. But what if I have 0 on top? What type of form did we call 0 over 0?
Indeterminate?
Indeterminate?
Indeterminate. So what if, in a similar way, the thing on top here is infinity? So that means I have infinity over infinity. Well, what did we just say division by infinity causes?
0.
0. And if I multiply something by infinity, what do you think I get?
0.
5 times infinity.
0.
Are you sure?
No, it's infinity.
Oh, yeah, my bad.
Okay. So division by infinity causes 0. Multiplication by infinity causes infinity. So kind of like when we said 0 over 0, division by 0 causes infinity. Multiplication by 0 causes 0. So it was like a battle of zeros. Infinity over infinity, I can think of as like a battle between the infinities. The infinity on the bottom is battling. It's like, this should be 0. The infinity on top is all, no, this should be infinity. Sometimes the result will be infinity. Sometimes the result will be 0, but sometimes the infinities will kind of balance each other out and end up with 84. So in other words, like 0 over 0, infinity over infinity is an indeterminate form. And I'll just remind you what it means to be an indeterminate form is that it's hiding some value. It can take on any value. It can be infinity, it can be 0, it can be 5, it can be 84. It's just hiding some value. You have to do more work to figure out what it is. So just a question, based on that definition, the idea that being an indeterminate form means it could be anything, is a constant over 0 an indeterminate form? Not 0 over 0, but a constant over 0.
It
No,
can be.
It
I
just
don't think
doesn't
so.
exist.
No.
Okay, so someone said I don't think so. Why not?
I mean, I'm not really sure, but what we've been taught is it just doesn't like
What are the
exist.
values that a constant over 0 can take on?
Any number and 0, or like infinity and 0.
So if I get like 5 over 0, what are the options for what that could be? That we were just doing up here. We were like, negative 9 over 0
minus
meant
infinity.
that it was one of 3 things.
Minus infinity or infinity.
Minus
Or
infinity or infinity. Could this be 7?
Yeah.
5 over 0, could it be 7?
Oh no, sorry. I thought you meant like the 5
No,
could be.
that 5 over 0 couldn't be 7. So what are the values that a constant over 0 could take on? Infinity? Negative infinity does not exist. Is it indeterminate?
No.
No. So those of you that were feeling like no, that was really good intuition there. The answer is no. An indeterminate form can take on any value in the whole wide world. Constant over 0
go.
cannot do that.
But
It can-
if the constant is equal to 0, then it can.
Right, but that's what I said. I said not 0 over 0,
Oh, okay.
some constant over 0. So 0 over 0 is indeterminate, but as long as we don't have a 0 on top, that constant over 0 is not indeterminate. Does that make sense
Yep.
to everyone? Good, okay. So then this is what we're gonna be mainly dealing with today. We're gonna be dealing with infinity over infinity. Division by infinity is just 0. Multiplication is just infinity. So the only things that we really have an issue with are if this shows up. So let's
I have
start off with a pretty straightforward, simple problem.
I have a question.
Yeah.
If we get infinity or like minus infinity over infinity, let's say the symbols
It doesn't
aren't
change anything.
doesn't change anything. Okay.
Yeah, so like this could be like a plus or minus, and this could also
Yeah.
be a plus or minus.
Just making sure.
Okay, so I'm actually going to do this problem in 2 ways. The first way is going to help us to get an intuitive idea of the way that I'm going to do it for the rest of the time. So I have the limit as x goes, oh sorry, that should be a plus x, my bad. The limit as x goes to infinity of 8x squared plus 6 over 3x squared plus x minus 2. When we have a limit, the first thing we always want to do is plug in. What do I get when I plug in here?
Is it
Infinity over
infinity?
infinity.
Oh, was that Luca?
Infinity over infinity.
I do, because infinity squared is still infinity. Infinity times 8, infinity. Adding 6 to infinity doesn't change a thing. Subtracting 2 from infinity, well, I'm still infinite. So this does give me infinity over infinity. So we're going to call this the method for developing intuition. And I'm never going to do it again. But it might be helpful in terms of thinking about this. What I'm going to do is I'm going to recognize that the highest power overall is 2. So in the same way as when I had 0 over 0, when I rationalized, I multiplied by 1. When I cleared denominators, I multiplied by 1. I'm going to multiply by 1 here. And I'm going to multiply by 1 in the form of 1 over x squared and 1 over x squared. So I have 1 over x squared over 1 over x squared, which is just 1.
Wait,
Yes.
why are we doing?
We're doing this so that we can develop intuition for the method that I'm going to teach you guys. So you'll see in just a second why this is going to be helpful for us.
Okay.
So when I take that highest power and distribute it, I have the limit as x approaches infinity of 8x squared times 1 over x squared. So that's just 8 plus 6 over x squared all over 3x squared times 1 over x squared. So that's 3 plus, what is x over x squared?
X. Oh no, sorry. It's
1 over
Where
X.
is the x left, the top or the bottom? What does x over x squared equal?
1 over X.
X.
1 over x. I have 1x in the top and 2 in the bottom. When I get rid of one of them, I have 1 left in the bottom. X over x squared. So I can kind of think of that as, and then minus 2 over x squared. Now I'm going to plug in infinity. And I'm going to get 8 plus 6 over infinity. 3 plus 1 over infinity minus 2 over infinity. But what does a constant over infinity give me that we just saw?
Zero.
0.
Yeah.
You got it. So this is 8 plus 0 over 3 plus 0 minus 0. And that gives me 8/3.
Holy shit.
And that's my answer. So by multiplying by that 1 over x squared, we were able to see that a whole bunch of that stuff went to 0 and was actually unimportant.
Wow.
Okay, I have a question. If we have, let's say, like from the beginning when we got to infinity over infinity,
Mhm.
if you had, let's say, 3x squared, or like 3x minus x, oh no, that would just be 2x. Never mind. Okay.
Okay. Now, like I said, this method right here is to kind of help us figure out why I'm going to do what I do next. So the method I'm actually going to use, the method that we're actually going to use to do this problem is a little bit simpler than what I just did there, or at least I think it's simpler. And I'm going to call this the take the big stuff method. So I'm going to do it on this problem, and then we're going to write what we did. So if you look at what we did up above, that 6 ended up just disappearing and becoming a 0. It wasn't important for my final result. The -2 and the x as well ended up becoming zeros and weren't important for my final result. When we think about this, the reason that that happened, if I am at infinity, so x is super, super, super big, what's the value of 8x squared when x is infinite?
Zero.
No, let me ask again. So stay with me, guys. 8x squared. What is the value of 8x squared if x is infinite?
Oh, it's infinite.
Infinity.
Infinity.
It's just infinity, right?
Yeah.
So if x is infinite, 8x squared is also infinite. 8x squared is super, super extra giant. What's the value of 6 if x is infinity?
6.
Infinity.
Still 6.
6. There's no x there. The value of 6 is just 6. So in other words, 8x squared is infinitely bigger than 6. If I add 6 to infinity, does that change anything?
No.
No. That 6 is
No.
so small when we get to infinity that it doesn't matter. I can just pretend it's not there. It is infinitely smaller than 8x squared. It's not changing anything. In the same way that -2 also doesn't matter. If I have infinity and I subtract 2 from it, that literally changes nothing. You guys see that? Now, what about between this 3x squared and this x? Both of those are infinity. But what is bigger, infinity squared or infinity?
Infinity squared.
Infinity squared.
Infinity squared. Is it actually infinitely bigger?
Yeah.
Infinity times infinity versus just infinity.
But it's still the same infinity, no?
It is still the same infinity, but what I mean is, like, if I had infinity squared, think about it like this. If I had infinity squared minus infinity, is the value still infinity?
Yeah.
Yeah. So like there's an infinite amount of difference between them. That subtracting of that infinity is small enough that it doesn't make a difference.
Okay.
Right? There's like an infinite amount of space between them. So that x, oops, also doesn't matter. The only thing that matters is the biggest term. So I can say that this is equal to the limit as x goes to infinity of 8x squared over 3x squared. Can I now cancel those x squareds out?
Yeah.
And what do I have left when I do?
8/3.
Did I get the same answer?
Yeah.
Yes.
So is this the method we're going to be using most of the time? For
This is the method
exercise?
we're going to use most of the time, yeah.
Okay.
And that top method was just to kind of explain how all of that stuff actually just disappears and isn't important.
Okay.
Okay, so what did I do here? I took the biggest term and only the biggest term from both the numerator and the denominator. So we're gonna write this method down. Take the big stuff. That's the name of our method. And when we're taking the big stuff, what we do is we take only the biggest term from the numerator and the denominator. Get rid of everything else. Then we use algebra to simplify and plug in infinity again. And when I use algebra to simplify, I should have no plus or minuses left. Okay, so we're gonna do this on a few more problems and just see how this can sometimes get a little bit more challenging than just what we had right there. Before I do that though, I want you guys to finish writing. Tell me in the chat when you're ready, and then we're gonna talk about infinity battles again. Four of you. Now we're getting critical mass here. Okay, so let's look at this function that we just did. I kind of was talking about infinity over infinity as a battle of infinities. In this particular one, it turned out that the infinities sort of balanced each other out. The top infinity wasn't stronger, making it infinity. The bottom infinity wasn't stronger, making it 0. They kind of balanced each other out, and we ended up with 8/3. So let's just keep that in mind as we go on to this next problem. And we're going to do the next problem by taking the big stuff. And actually, I'm going to put a circle around this because it's a method. Okay, so I plug in. In this case, I get negative infinity over positive infinity. I have my infinity war happening. Negative 4x plus 2. What's the big stuff?
4x, minus 4x. Yeah.
Minus 4x. So I'm only keeping that minus 4x. That 2 is infinitely smaller. It's unimportant for me. What am I going to keep in my denominator?
8x squared.
You got it. That's 6. Unimportant. So right now, from here, I should easily be able to see which infinity is stronger. Do I have a stronger infinity, or are they going to balance each other out? You got it, Luca. That bottom infinity is stronger. If the bottom infinity is stronger, what should the answer be?
0.
You got it, 0. Right? We said if the bottom infinity wins, we're going to get 0. But we can continue on and see that. If I simplify this, I'm going to get the limit as x approaches negative infinity of -1 over 2x. So just to make us see this, -4 over 8, that's -1/2. And we talked about this a second ago, x over x squared is 1 over x. So now when I plug in, I get -1 over infinity, which we know, which we've seen to be 0. The bottom infinity was stronger. We got a 0.
Miss,
Yes.
when you put you replace 2x with infinity.
Yeah.
Wasn't the limit for negative infinity?
Yeah, that should be a negative there. You're right. Negative. My bad.
Okay.
It doesn't change the answer.
It doesn't
though.
change it, yeah, but I'm
Yeah,
just.
but it should
I
be a
was like,
negative infinity. You're right. Thank you. I'm not that great at negatives. You'll notice they just like pop up in places where they shouldn't and disappear in places where they should be. They're not my favorite. All right, you guys ready for the next one?
Yep.
Okay. Ah. What am I going to keep in the numerator?
8x squared.
Do I need to keep the 9x too?
No, because it's infinitely smaller.
It's infinitely smaller, it can be gone. I'm only keeping the one biggest term. You'll notice I said that there should be no remaining pluses or minuses. I'm not going to have 8x squared plus something. I'm only keeping the one biggest thing. So goodbye, goodbye. Are there any questions about that? Good. What about on the bottom? What am I going to keep?
Minus 4x.
So now this 8 over negative 4, that's negative 2. Limit as x approaches positive infinity. What is 8x squared over negative 4x equal?
2x.
Minus 2x, you got it. And when I plug in my infinity, I have minus 2 times infinity to give me a negative infinity. What's infinity 1 here?
Top one?
The top one. And if we look at it, we're like, there's that x squared on top, that x on the bottom, the top infinity 1. If this had been x approaches negative infinity, what would the answer have been?
Just infinity.
It would have been positive infinity. You got it. So when in the case where the top infinity is stronger, like this case, we have the higher power on top, that top infinity is going to win. We really need to be paying attention to if we're plugging in positive or negative infinity, because it could change the sign. Whereas in the other cases, it's not going to do that. Okay, are there any questions about this? So these were pretty straightforward. It was pretty easy to see what the biggest term was. So now the question is, what if instead of just having a nice, simple, expanded polynomial, I have a polynomial in a factored form? So what if there are multiple factors? So you might look at this and be like, okay, well, how am I going to take the biggest term? How am I going to find what the big stuff is? Let me expand. There's actually no need to expand. I don't care about what all of the small stuff is. I only care about what the biggest term is. And to find out what the biggest term is, I can just take the biggest term from each factor. So in other words, there is no need to expand. So we'll do this in red. No need to expand. Just take the biggest term from each factor. And sometimes it's actually going to be unreasonable to even think about expanding. In this case, we could, but we're not going to. So I'm going to look at 9 minus x. What's the biggest thing there?
X.
Do I need to take the negative with me?
Oh, yeah, minus x. Yeah.
I'm going to take the minus x. So taking the coefficient is important. What about in the 7 plus 3x? What's the big thing?
3x.
You got it. 3 minus 2x?
What?
Minus
Oh,
2x.
Minus 2x,
Yeah.
11 plus 10x.
10x.
Ta-da! So I'm taking the big thing from each factor. And this gives me the limit as x approaches infinity of minus x times 3x over minus 2x times 10x. Take a second, make sure you understand what I just did here. Ask questions if you have them. We're good. So guess what? X over X is equal to 1. And this gives me the limit as X approaches infinity of -3 over -20. So my answer is 3 over 20. Okay, so I'm going to do another one like this. Actually, I want to make a conclusion that I haven't been making, I've been meaning to make, and I keep forgetting. This tells me that there's a horizontal asymptote at y equals 3 over 20 as x goes to infinity. What about in the previous question where my answer was negative infinity? Was that a horizontal asymptote?
No.
No. Remember we said if the answer is infinite, there is no horizontal asymptote. And I want to point out that it's also not a vertical asymptote because x is going to infinity. And vertical asymptotes need to happen at places. X approaching infinity means I'm not going to have a vertical asymptote. Okay, so we're going to do a couple more questions here. And we're going to see why being able to just take the biggest term from each factor is so useful. Okay. Question. Would it be fun to expand this thing?
No, it'd be very long.
It'd be very long. Like, even I wouldn't think that's fun. And I really like doing math. So if I don't think it's fun, that means it's probably really not fun. So like expanding this thing would be really long and really unpleasant, and would it be unreasonable to have to do that in a simple limit problem like this? So being able to take the big stuff from each factor is super important in this case. What's the big stuff from my first factor?
X cubed
X cubed.
You got it. I'm just taking the x cubed. From the second,
minus x squared,
take the minus x squared. From the third,
2x.
good. So then in my numerator, I have x cubed minus x squared times 2x. And what about for my denominator? How many factors do I have in my denominator?
2x. Oh, you're taking 2x to the power 4 and minus x to the power minus x cubed.
You got it. So in this case, it's going to be important to remember our algebra rule. What does x to the a times x to the b equal?
X AB.
A plus b?
X to a plus b, yeah. So with that in mind,
X to the power 6 over x to the power 7.
yes, so I'm going to have negative 2x to the 6 over negative 2x to the 7. Do you guys see how I use the algebra rule to get that? And the negative 2's cancel out. Which infinity is going to win? The one on the top or the one on the bottom?
Bottom's gonna be 1 over
The bottom. So what's the answer going to be?
0.
0. I can see that right now. I can write down 0 if I want. I'm still going to go one step further. The limit as x approaches infinity of 1 over x, that gives me 1 over infinity. And so now I can see that the answer is clearly 0. And this means that I have a horizontal asymptote at y equals 0 as x goes to infinity. Are there any questions about this? All right, then, we have one last thing to talk about. And that is, what if, aside from just having multiple factors, I also have powers? So we're going to do an example of what I mean by powers. So I have the limit as x approaches negative infinity of 5 minus x squared times 2x plus 1 cubed over x squared plus 2x plus 9 squared times 3x minus 1. Okay, so again, my ultimate goal is to figure out what would the biggest term be if this were expanded. I can do that in the same way that I did in the last, where I take the biggest term from each factor. So for a second, I'm just going to pretend that those powers aren't there. 5 minus x. What's the big stuff?
Minus x.
Good. So I'm going to take that minus x. I'm going to take the power with it. So in other words, I take the biggest term from each factor, but I put them to the necessary power.
But when the minus like multiply by itself, so it become positive?
It is going to become positive, and that's an important thing that we're going to like point out in the next step there. So that minus is also going to be to the power of 2.
Yeah, okay.
Okay, so I'm going to have the limit as x approaches negative infinity of negative x squared. What about the big step from 2x plus 1?
That's 2x?
2x. Am I going to take the power of 3 with that?
Yeah.
Yes. So I end up with 2x cubed. So be careful here. As David just pointed out, the negative and the 2 are inside. The negative and the 2 are also to the power.
So it'd be 8x to the power 5?
You got it, exactly that. And we'll do that in 2 steps. So also to the power. Good. What am I going to take in the denominator?
X squared to the power 2?
X squared to the power of 2 and 3x. And I'm going to remind us of another algebra rule here. If I have x to the power of a all to the power of b, what's that?
X to the power AB.
You got it. So I'm going to multiply those things together. So x to the a times b. So up here, be careful. So this is what David was asking about a second ago, that negative x squared. So I'm doing negative x times negative x, it becomes positive. So I have x squared here. 2x cubed. The 2 is also being cubed, so I end up with 8x cubed. X squared squared, here I'm remembering that algebra rule down here. I have x to the 4th times 3x. And now I can use my other rule to see that this gives me 8x. What's the new power on top?
5,
5. And what's the new power on the bottom?
5, 8 over 3.
You got it. So we have an 8 over 3, again, just in a different way. And there is a horizontal asymptote at y is equal to 8/3 as x goes to negative infinity. And we are done. I will post the horizontal asymptotes practice sheet for you guys. You should be able to finish your web works now, all that kind of stuff. If you don't have any questions, we're done.
All right, thank you.